Look closely at the modern internet, and you will find an ecosystem operating entirely out of view. Thousands of hidden nodes are active right now, trading data and building networks that standard browsers cannot see. Navigating this environment requires specific protective infrastructure. This bar chart tracks the financial toll of global cybercrime. In 2015, the annual cost sat at roughly $3 trillion. By 2025, that number is projected to hit $10.5 trillion. To understand how that financial damage happens, look at the volume of personal data exposed. In July 2024, the RockU 2024 leak alone dumped approximately 10 billion unique plain text passwords online. Law enforcement agencies occasionally disrupt major players, but when the FBI dismantled high-profile ransomware groups like Lockbit or Alfie, the underlying ecosystem simply adapted. New operators stepped in to fill the void almost immediately. Staying secure today means you have to understand the specialized networks where this data is actually hidden, traded, and, importantly, protected. If you are using a standard web browser like Chrome or Safari, your IP address is exposed. These tools are built for the public web, meaning they physically cannot access the hidden layers where true anonymity exists. This proportional Venn diagram breaks down the internet's actual architecture. The surface web is the most visible part of the network, but it's small. Beneath it is the deep web, unindexed pages that make up roughly 96% of the internet. And nestled entirely inside that is the dark web. This space serves two entirely different masters. One side harbors illicit markets and cybercrime forums. The other side provides a vital lifeline for whistleblowers, journalists, and citizens evading government censorship. To access this layer and achieve real anonymity, you have to use an overlay network. But there is a direct trade-off. Stripping away your identifiable data means sacrificing speed and convenience. You have three primary options: Tor, I2P, or Freenet. Choosing the wrong architecture for your specific needs will either expose your identity or make the internet so slow it becomes completely unusable. We start with the Onion router, or Tor. It has the largest user base and the most community funding. Its primary design goal is simple: mask your identity while you browse the regular public internet. Tor's onion routing encrypts data, bouncing through 3 relays before the public web. Security relies on limited visibility. Middle nodes only see the immediate previous and next connections. After 10 minutes, the circuit is killed, and requests route through new nodes to thwart analysis. Tor's biggest advantage is accessibility, providing a pre-configured browser right out of the box. But its design creates a specific vulnerability. To reach the regular internet, your data leaves the encrypted network. This final hop, the exit node, is a potential exposure point. Routing your traffic across thousands of global miles also requires resources. Out of the 3 networks, Tor has the lowest bandwidth utilization, which translates to noticeably slower browsing speeds. Tor is an excellent accessible tool for masking your IP address from public websites, but the moment your data crosses back onto the surface web, you lose the guarantee of absolute security. If your goal is to avoid the public internet entirely, you need the Invisible Internet Project, or I2P. This diagram illustrates I2P's packet-based routing. Every user has 2 distinct one-way sequence paths, an outbound tunnel for sending and an inbound tunnel for receiving. You control the length of these peer sequences. Adding more peers increases anonymity, but you pay with higher latency. While Tor connects you to the outside world, I2P focuses on creating a secure network within the internet. It is highly optimized for dynamic hidden services, torrent trackers, and peer-to-peer file sharing. This creates a dynamic, decentralized mesh. If a router goes offline, the network seamlessly reroutes your data, making it highly resilient against targeted attacks. The trade-off here is steep. I2P does not come with a simple browser. You must install the software manually, configure your own proxy settings, and abandon standard surface web access. I2P discards user-friendliness and surface web access, but in return, it gives dedicated darknet operators a highly secure, closed environment for sharing data. Freenet operates on a completely different premise. It isn't a proxy service at all. It's a peer-to-peer platform built exclusively to prevent information censorship. This visualization shows how Freenet handles data storage. To join, you contribute hard drive space. Published files break into encrypted fragments and scatter across participating users. You have absolutely no way to decrypt the fragments stored on your machine, providing you with crucial plausible deniability. The storage system is evolutionary. The network automatically replicates and preserves highly requested popular content. If a file is ignored, Freenet automatically discards it to make space for new data. Freenet also includes a specific darknet mode. This allows you to configure your node to connect exclusively to the IP addresses of people you personally know and trust. Retrieving a file requires the system to pull these fragmented pieces back together from across a completely decentralized global mesh. That process is heavy. You are required to contribute a significant amount of your own bandwidth to route these requests, and Freenet suffers from the absolute slowest operational speeds of the three networks. You sacrifice speed and dynamic interaction entirely, but in return, Freenet gives you an indestructible vault. Even if the original publisher goes offline permanently, their data remains accessible as long as the network values it. Because no network is perfect, your decision comes down to what you are actually trying to achieve. Look at this decision matrix. To mask your IP address while browsing the public internet, Tor is the only practical choice. To host dynamic hidden services and share files peer-to-peer, you need I2P. To publish static documents that resist censorship, choose Freenet. But here is the reality check. The most advanced routing architecture in the world cannot protect you from human error. None of these tools guarantee protection against timing attacks. They will not stop you from falling for phishing links, and they certainly cannot protect you if you willingly type your real name or identifiable information into a forum. Maintaining actual anonymity depends on matching the correct network architecture with consistent, disciplined behavior.